Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter one, thinking critically, but after we went over section 1.8, living in media age, where we covered most of the common fallacies, and also we introduced the notions of propositions and truth values that we understand the and statements, the conjunctions, the or statements, the disjunctions, the conditional propositions, etc. So in the first two sections. So now we're going to take a look on the set and Venn diagram. So that's extremely important to take a look on the previous videos if for any reasons you miss what we covered where especially the previous section that we examine the propositions that comes in many forms. So let's say the only general requirement for a proposition is that it must be a sentence that make a clear claim, assertion, or denial. So what we're gonna do in this section, especially, let me go over it very quick. The sets and Venn diagram. We will focus on proposition that claim a relationship between two categories of things. For examples, let's say proposition like all walls, all walls are mammals you know, makes the claim that the category walrus is entirely contained within the category mammals, right? So propositions of this type are most easily studied with the aid of two key ideas. The first one is the set. We're going to see what are the sets. A set is a collections of objects. It's really just another word for a collection, so collections of objects. The second is the idea of a Venn diagram. We usually use Venn diagram to represent sets that can either mutually exclusive or mutually inclusive, right? It's a mutually exclusive or not mutually exclusive. So we're gonna see this one. It's a certain way, simple way to visualize relationships among sets, right? So both ideas are very useful for organizing information and are very important tools for of critical thinking. Now let's talk about sets. As we said, a set is a collection of objects, living or non-living. But the members of a set, they are the specific objects with it. So we said the members of a set are the specific object with it. So we represent a set by listing their members within a pair of braces. So, for example, we said there's two ways to we can either use set builder notation. For example, set A is a day of set A represent the days of the week. All right, represent the days of the week. Let me say remove is, okay, represent the days of the week. So once you see that, what is A? A, we said, first of all, we use capital letter for the set. So never use a lowercase letter. So we use capital letter, capital A represent a set. Now we need to use a pair of braces. Like first of all, I open it. What are the days of the week? It's Monday, Tuesday, Wednesday, off for Thursday, Friday, Saturday, and Sunday. You see, those are members of that set, or we call them the elements of that set. right? So if we have that set of the days, set days of the week, okay? So those are the elements of that set: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we know what are those the elements, or we can say set A, or I can set A, you know, natural, even number less than 12, less than 15. Okay. So what are the elements of that set? Remember, I said the set, you can list the element. That's called a listing method. But the first one is not really a set builder notation. I'll show you how to write set builder notation, but let's list them. What are the elements of set A? Because I use A already, how about we use B for now? Because you can use any letter. Usually we start with A, but we can use also B, first letter of your name. Also, that would be fine. What are the elements of that set? First of all, you need to ask yourself, what are the even natural number? What's a natural number? Yes, the set of natural numbers are all positive numbers excluding zero. So zero is not part of it. So natural numbers are numbers from one, two, three, four, five. No negative, no zero. All right, no fractions, no decimal. So the natural numbers are all whole numbers from one to infinity, but all positive, starting with one. But what happened, I don't say natural numbers, all natural numbers. We're gonna take only even number. Now, for the even numbers, if we don't say where to stop, we can go indefinitely as well. But because they said less than 15, natural numbers less than 15, even, we cannot take zero, we cannot take one. We do two, four, 6, 8, 10, 12, 14. Are we done? Or no, yes, because it said less than 15. That's it. But some sets, we said, after we use, as I said, a bracket to represent those sets, you need to list the members of the sets within a pair of braces, okay? And each member separate from the next one by a comma. Very important, but some sets have so many members that it will be very difficult or impossible to list all of them. So in this case, we use what we call ellipsis points. You see those dots, so we use three dots. That's we call also ellipsis points. The three dots to indicate that the list continue in the same basic manner. So the three dots are called an ellipsis, but most people just say it's dot, 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 right? That's how you read it. So if the dot comes at the end of a list, they indicate that the list continues indefinitely. But it can start from it also. The three dots indicates that the list continues as you would expect. In this case, with the names of all other elements, right? So for examples, if we let me write an examples for this. So I'm gonna set T, okay? Um I'm gonna set of let me put a set builder notation X such that X is an integer. All right. Now, what are the integers? That you need to remember also. Integers are all, because when we talk about real numbers can be, you can have, numbers can be either rationals or real, but when we say real numbers, we have all the natural numbers, positive numbers, one, two, three, four, five, six, seven. And we have whole numbers. Whole mean you spell WHOLE, whole numbers. As you can see, there is a hole on it. Like so there is an HOLE, hole on it. So that means zero is included. All positive numbers, including zero. So you need to start zero, one, two, three, but no negative, no decimal, no fractions. All right. And then, integers are all numbers, negative, positive, zero, except fractions, except numbers with symbols, except decimal, the positive decimal, negative decimal, we cannot have those. So be careful when you check those because you cannot have that. But you know, not integers are all numbers, as I said, that are positive or negative. Because we cannot list them all, what can I do? I know we come from negative infinity, negative billions, negative trillions, negative millions, negative thousands, hundreds, and then we're gonna go down until we get to positive. Let's suppose these three dots mean I come from the all the negative, and let's suppose I take negative 4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And I can continue indefinitely because I can continue in both sides indefinitely. You see, I put ellipsis point on the left and on the right. It may happen if I said, oh, set C. X such that X is a natural number. If I said natural numbers, then I'm not gonna start from the negative. I'm gonna start from 1, 2, 3, 4, 5. That means my ellipsis point would be only on one way. So we need to verify and pay attention to this one. That's very, very, very important to understand the definitions of a set. All the elements in a set, so we need to pay attention to it. Okay, that's important. Now, Venn diagram, John Venn was, invented by John Venn. Venn diagram is a different way we use a diagram that we use is circle to represent sets, right? So maybe you would have a chance to look what John Venn, the English logicians, I think it was. Um, he lived from 1834 to 1923, so that was a long life, right? Invented a simple visual way of describing relationship among sets. So his diagram, I mean, this diagram now they call it Venn diagram because that was his name. His name was John Venn. So that I mean, I think this guy was a an ordained priest who wrote books on logic, statistics, and probability, right? He also wrote a history of Cambridge University, where he was both a student and a teacher, well respected for many of his contributions. So logic, he is best known for the diagrams that bear his name. Otherwise, we wouldn't have this, the same way we have the Cartesian coordinate planes, we have the Pythagorean theorem. So those guys has their name, but these diagrams, as we said, use circles to represent a set. So Venn diagrams are fairly intuitive and best learned through examples. So we're gonna use a few examples to explain it. But before we get there, let's see about these examples right here. We said use set of notation to write the members of the following set or state that the set has no members. You may use Twitter to etiquette patterns. So patterns means if I said 2, 4, 6, 8, the next one would be 10, right? So we call that pattern. All right. Now let's go with our first examples. In this, very important, they said the days of July. So let's say I'm gonna call this set right there A. So what is the set of A? Right? If I list all the elements of A. Now, our goal is really to list the elements of A. So dates of July. What are the dates of July? Yes, July has how many days? 30. So we can list them. Not zero is not in it. So those are all natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, until you get to 31 because July has 31 days. But because I don't want to write all of them, I put three ellipsis point in the middle, meaning follow the patterns because after one, I put two, after two, three, after three, four, after four, five, after five would be 6, 7, 8, 9, 10. But I said until we get to the end, like we have the 29, the 30 and the 31. I go up to 31 because the month of July has 31 days. Now, because I don't have enough space, how about we put B here? For B, they said the state that shared a border with the state of Mississippi. So you will need to know your the American map for to understand it. Because for me personally, let's consider this one as B. Set B. For those of you who are Americans, born and raised and went to school here, or even though you were not born and raised, but at least you studied the U.S. History and geography, so you should be able to look at all the states that border Mississippi. So, you know, because I look at it, I know it would be Alabama, but feel free to double check because I might still make mistake about it. There is after Alabama around, so I think Alabama is in this some types of in the west or east or south, of Mississippi. We have Arkansas. Maybe you need to check this one also. Arkansas. We can also find the Louisiana. And what I found also is Tennessee. So please, Tennessee, no, two N's. Right? You have two N's, two S's, two E's. So those are the sets. As you can see, I use a pair of braces and also I use a comma to separate each element, each member of the set. So that's B. Remember, as you know, some of them has nothing to do with math. It's about the common sense or your daily experience of life. Like if even do you know math or not, if they ask you what the name the state that share a border with the state of Mississippi, it's not math. It's like things that you need to learn, especially geography and and history that will help you. Next one, the perfect squares between 10 and 40. Perfect squares between 10 and 40. Here you kind of need some math, right? Perfect squares between 10 and 40. What are the perfect square? Let's call this one C. All right? Remember, I use capital letter. Perfect square. What are perfect squares? Perfect square are the numbers when you take the square roots, it would give you a whole number. For example, 4 is a perfect square because square root of 4 is 2. Okay, 9 is a perfect square because the square root of 9 is 3. So it's any numbers when you multiply by itself will give you that perfect square. For example, if we go with 100, perfect square because square root of 100 is 10. Let's say if we take 64, square roots of 64 is 8. Now, between 10 and 16, choose some of them. Which one? You cannot take 12. There is no number you can multiply by itself to give you 12, right? No 14, 16, right? 4 times 4 give you 16. I'll take 16. Then what would be the next one? If you do 4 times 4, 16, what's the next? Yes, 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. But we don't need to go to 49 because they said they asked us only between 10 and 40. Okay, because we cannot make 9, 3 times 3, 9, 9 comes before 10, but they said 10 to 40, so we cannot reach any number above 40. So if we take 49, 49 would be above 40. So that's at some point what we do. I believe you understand what I'm planning on doing here with all these examples. So now let's move forward with what we're planning on doing with these. Let's say, for example, Um, I think you can do anything else we have here, okay? So hoping you can do it. Now let's go with you know, um the Venn diagrams. We studied the Venn diagrams. We said Venn diagrams, John Vane, for if we consider that's about one examples I said at the beginning. I'm hoping my accent didn't stop you from understanding. We said if you consider the set of wells, you know, Wallace, wells, okay, the set of wells and mammals, okay. We said because all whales are mammals, we say that the set whales is a subset of the set of mammals. You see, the set whales is a subset of the set of mammals because all whales are mammals. We represent this representation in that Venn diagram you can see here. All right, that's very important. In that Venn diagram, we're drawing a circle to represent the set of whales. Okay. Inside a circle representing the set of mammals. So notice that the Venn diagram illustrates only the relationship between the sets, right? The size of the circle doesn't matter. You can do a very small one, but you see we use a rectangle because anytime you construct a Venn diagram, you have circles that represent the sets, and you have the rectangle that represents the universal set. That means everything that is possible at this point for the sample space. Now, another, we can talk about is fish. Okay, so we said other animals that you can see, they are in the, they are in the water, but they are not. Okay, they are in the water, but they are not mammals, right? We said all whales are mammals, but at some point here, we can conclude these are not mammals, but they are also other animals, right? Because the circles are enclosed by rectangles, as I said. Okay, that's very important. Now, we call these two sets, okay? Uh, because they are animals but not mammals, so we call these two sets they are disjoint set. Disjoint, that means they don't have something in common, all right? Even though we use circles to represent the sets. Now, at some point, if you consider a set of doctors and female, we can say these are overlapping sets because it is possible for a doctor, for a person to be both. That person can be female and doctors at the same time because of the overlapping regions. We know they have something in common. So the overlapping region represent the people who are doing both. People who are also female doctors. On the other side, we have all the other doctors that don't identify themselves as female doctors, and we have all other females that are not doctors. Probably those females are engineers, but we have females and we have female doctors with everyone. So the set of doctors and women are overlapping. That's very important to verify that the non-overlapping region of doctors circles represent doctors who are not women, and the non-overlapping region of the doctors circle represent, uh, uh, you know, doctors that are not women. Okay, so hoping this one help. We're gonna go over some other relationships in Venn diagram. So sets relationship in Venn diagram. As we said, A may be a subset of B or vice versa, meaning all members of A are also members of B. That's whales and mammals, right? So that's what I just said. The Venn diagram for this case shows the circle for A inside the circle of B. That's the first step. And let's say A may be disjoint, we just covered that, from B, meaning that the two sets have no common factors or no common elements, right? So the Venn diagram for this case consists of separate circles that do not touch. These two circles have the overlapped, okay? Now, A and B may be overlapping sets, meaning that the two sets share some of the same members, right? You see where they are overlapping. So the Venn diagram for this case consists of two overlapping circles. We also use overlapping circles for cases in which the two sets may share common factors. And of course, I strongly advise you to read everything you see in this section because it's very important to review all your sets. Okay, so we're gonna go with some other questions about sets, very quick things you can do. All right. The first one, draw Venn diagrams. I'm gonna just put a copy very quick on this. Do Venn diagram. Let's do the first one. Okay. Draw Venn diagrams with two circles showing the relationship between the following pairs of sets. Provide an explanation of the Venn diagram you draw. So here they said, for me, teachers and people with driver's license. So we have, because some teachers have driver's license, do you think they're gonna overlap or not overlap? Teachers, we have two sets. We have teachers, we can call it A, and people with a driver's license, we're gonna call it B. Do you feel like in my circle right there, where I would represent these two sets A and B using a circle, would they be subsets, disjoint, or overlapping? Yes, it would be overlapping. I'm gonna put it like this, where I said this is A and this is B and this is the universal set. This is the whole set. So because what happened, we can say that there are teachers that have driver's license. So the circles overlapping, we know they have that particular place in common, right? So for us, this is teachers. We said people with driver's license, okay? We can say driver's license. Now that's how we're gonna see for this example, right? But feel free to go over any other examples because we can still do it. Hold on. All right. Now I think I'm gonna do number 2 here also because we have enough space for it. Skirt and clothing. So let's call this one A and let's call this one B. We said and. Now, what you need to verify on this one, okay, are they overlapping subsets or disjoint? So we can say, do you believe all shirts are clothing or all clothing are shirts? Yeah. If you say shirts, then they are clothing. That's a subset. So for us, it's construct a circle. Okay. We can construct a circle or we can do it. You know what I'm gonna do? I'm not gonna do a circle. I'm doing the rectangle. Inside of that rectangle, I have this big one that I would call clothing. And that's B because I call B clothing. And inside of B, I'm gonna have A. Why I say that? Because all shirts are clothing. Shirts are clothing. And now this set of shirts is the subset of this set of clothing. This means one circle should be contained within the other. And that's how we're gonna do it. We can go and do more examples. Let's probably go with the third one. I'm gonna again do here. Okay. For number 3, let's go with number 3. For number 3, again, I go with a circle. Okay. For number 3, I'll go with a circle that represent for the Venn diagram. Now we have two sets. The first set we have a set poem and we have a set plumber. Okay, so poem, plumber. So we need to verify those very quick. Plumber, now I don't know. Do you believe there are plumbers that are poets, or there are poets that are plumbers? Or all, I mean, the first question to see if it is upset, do you think all poets are plumbers? Nope. Do you think all plumbers are poets? Nope. So it's not subset, right? It's not, it's inside of the other one. Disjoint. Do you think if you are plumber, you cannot be a poet? Or if you are a poet, you cannot be a plumber? That's disjoint. No. But do you think you can be both? Yes, so it's overlapping again. So we're gonna go, they have something in common right here. Then I can call this one A, this one B, because they are overlapping, right? We're gonna do one more, okay? One more. Let's do this one because the last one, 5, right there. Okay, remember we go with a circle, okay? Now you answer the questions. All right. If I said that teenagers are set A and octogenarians are set B, okay. Subset means all teenagers are octogenarians or all octogenarians are teenagers. Is that true? No. Okay, let's see disjoint. If you are teenagers, you cannot be octogenarians. Or if you are octogenarians, you cannot be teenagers. Is that true? Yes, so that's disjoint. No connection between these two because you cannot be both. That's A and that's B because no teenagers is in octogenarian. Also, these sets are disjoint and the circles should not overlap, right? So I'm hoping you use these examples to push and push and push and do more examples because here, what they ask you to do, we need to draw, okay? What we're gonna do, we're gonna draw a Venn diagrams, okay, with 3 overlappings. Oh, we have 3 of them. Let's say for A, look at what you have for A, okay? Verify very quick what you have for A, then we're gonna do it, okay? For A, they said, first of all, if we go with A, you know what? Let me close. I'm going to delete and put here. So we do A right there. Okay. The first thing, if you construct a Venn diagram, don't forget you need a rectangle, right? Now, from your rectangle, it tells you you must construct 3 circles. That's overlapping. Draw Venn diagrams with 3 overlapping circles for the following groups of 3 sets. Describe the members of each set. So I'm gonna put W for women to make it shorter. I'm gonna put R for Republican. And I'm gonna put C for Chiefs. Okay, that means overlap. I have the first circle. I have another circle. And I have another circle. So please, as you can see, there is a common factors for each of them. So you have A, Sorry, not A. We're gonna have this one is women. We're gonna call this one women. We're gonna call this one Republican, and we're gonna call this one C. So as you can see, it all depends on what you want to do here. Right there, it is R and C that you can write also like R intersect C. If you look at for here, it is W and C, or you can say W intersect C. That's the intersection. And if I take a different color so far, let's try which one I can go. I'm gonna go with yellow. So no, it doesn't go. You see? So this one is W and R, or R intersect R. W intersect R. But the most important part, if you see it here, you know, is this one. No, I'm not gonna use this one because I want to make sure I put one that you can see. Or maybe I need to take yellow. See? For the yellow part, that means the intersection of all of three. W and R and C, meaning we have W intersect R intersect C. That means everything these three has in common would be in this one. Then after you have W by itself, you have R by itself, and you have C by itself for the other one. So remember here, all right, so you only have W on W here by itself, okay? And you have, you know, each of them. So what we need to do here, okay? Remember here, we're gonna have only women. So for us here would be only women. Here would be only Republican. And here would be only chief. Okay, so then after there are some common factors. All right, if I do only one, I'm pretty sure you can do the others. So the goal for me, words that begins with T, nouns, and words that begins with fewer than five, you know. So that's another examples we could do, you know, but I'm pretty sure you can do it on your own. So remember, we have three of them. Words that begin with T, let's say A. Words begin with T. Okay, B. Words begin with nouns. C. I mean three sets. I choose it. Words with begin words with fewer than five letters. Words it make it simple. That's why I decided to do this one, because it make it so simple when you construct your rectangle, and inside of your rectangle you decide to go with 1, 2, and 3. So you know that's supposed to be beautiful circles. So if they are not beautiful circles, then you know, remember this one would be A. Words begin with T. Words begins with nouns, and words begins with fewer than 5 letters. Okay, so that's what we ask us to do. I'm hoping you can do this, and you know, and I'll be happy to do more examples. when you understand all of this. Some other examples you can see very quick, category or categorical propositions, we're gonna cover it here, for these after we see all the Venn diagrams, hoping you understand. That's no problem with you. But when we talked about categorical proposition, know that we have discussed general relationship between sets. We are ready to study proposition that make claims about sets. For examples, remember we talked about the proposition all whales are mammals makes a very specific claim, namely that the set Wallace is a subset of the set mammals because it was a subset. Proposition of these types are called categorical propositions because they claim a particular relationship between two categories of sets. Okay, so categorical proposition must have the structure of a complete sentence. So it's very important to remember how you can verify categorical propositions. Okay, they must have a complete sentence. That's very important. Okay, and one set appeared in the subject, the other appears in the predicate. Okay, so we can go over and over and explain this multiple times. For examples, in the propositions, as I said, you see all Wallace are mammals. The set Wallace is the subject set. And the set mammals is the predicted set. We usually use the letter S to represent the subject set and P for the predicted set. So we can rewrite all whales are mammals as all S are P, where S Wallace and P mammals. Okay, so that's a certain way of seeing it. We can review all the examples we covered before. All S are P, all whales are mammals, no S are P, no fish are mammals, so that's disjunct set, okay? And we can also see some S are P. That means some doctors are also psychiatrists, right? The X represent the overlapping. So some doctors are psychiatrists, or some S are not P, right? So if you read only where there is nothing in common, some foods are not vegetables, as an examples, right? We have different ways of seeing it, as an examples. All right. Now, if you construct a Venn diagram, remember it's very important to review, when you construct a Venn diagrams, after you see categorical propositions, for us, it's important to construct a Venn diagrams, and it all depends where you need to identify whether you're dealing with only one, or you're dealing with two, or you're dealing with three sets. Okay, very giantly important to see that when you construct a Venn diagram. So some dogs can swim. Refers it, some dogs are animals that can swim. So we can have a category of animals, all animals, and dogs will be a part of those animals, right? But not all uh, I mean, dogs are not totally inside of the animals who can swim, right? S is dogs, P is animals. Remember, we said we use the P for predicted, okay? And we use S, we use P for predicted, and we use P for, sorry, S for subject. Okay, that's very important. Because for us, one of the things we did, I'll probably show you to understand the subsets. Let me introduce. Let me include a. Yeah. We may have said about the set of real numbers, set of real numbers. different ways of doing it. I can say like, oh, the set of real numbers. Maybe I know I have that represent real numbers for me. Real numbers. Okay. But inside of real numbers, remember we have also rational numbers. So if I include the rational numbers, they are all real numbers. So that's what I put them all inside. We call them subset. So this is rational numbers. Rational numbers are all numbers that are positive, negative, zero, fraction, and decimal. So rational numbers is like everything, almost everything. Rational numbers, okay? Rational numbers, okay? And then we also have the integers. The integers are also, um, are also rational numbers, but they are also real numbers. If we put the integers inside, integers, just to show you the importance of these subsets, right? Let's go after integers. Yes, you have whole numbers. Whole numbers are all numbers. Integers are all numbers, positive, negative, but no decimal, no fractions. But whole numbers, remember whole numbers, they are numbers that are all positive, including one. Then the last one you're gonna have is the natural numbers, right? Natural numbers. But of course, if we said all of this, we know we can also have real numbers somewhere here. We can add irrational numbers. Irrational numbers are not. If I put it here, that means those are also irrational. You know what? It's better I put irrational somewhere outside of here. They are real numbers, but irrational. Irrational are all numbers with symbols like pi, rational numbers. Okay, yes, rational numbers. Okay, that's very important this way. Now that okay, we see this, it's important that you understand how it's gonna work. But I'll go ahead and complete some examples with you over all these exercises. Now the next one, they said okay, they said according to an exit polls from 2020 presidential elections, Joe Biden receives 44% of the vote among the white women, 90% of the votes among black women, 38% of the vote among white men, and 79% of the vote among black men. Show this data in a two-way table. So all they ask us to do for this one is to construct a two-way table. So what we're gonna consider as a two-way tables, look, very easy. Um, let's see. But they talk about men, female and male, right? Let's say women first. I could put men first, but I put because they talk about, okay? That's now. They said also, did we talk about white and black? I'm gonna put white and black. They said a two-way table, so I don't know why I do that big one, but we could just go ahead and, oh, I cannot do better than that. You know what? Okay. Okay, this is my two-way tables. Now, let's fill it all in. According to the exit polls from 2020 presidential elections, Joe Biden received 44% of the vote among white female. 44% of the vote, white female. 90% of the vote among black women. So 90% would be down here. Okay? Women, black, you know, we don't need to add up. We only need to show this data in a two-way table. Now, about men, they said 38% of the vote among white men. So white men is 38%, and 79% of the vote among black men. So 79%. Okay. And that's all. That's all they ask us to come to show over here that is not a problem. Right? So I'm hoping you like these examples. Definitely there are a few other ones that we can do. I'm gonna go very quick on this one. Probably it's not that difficult, but we still need to review and answer a few questions from this one. Okay. The first thing we're gonna do here, they said use the Venn diagram to answer the following questions, right? What I'm gonna do is probably stop and come back because I don't want this video to be too long, and also because I want to make sure we take enough time to complete these examples. Stay there with me. I'll be back in a few minutes to complete this section. Take care.